Good morning everybody and welcome to Monday the 6th of April. We are looking at the Corbett Maths Foundation 5-a-day sheet and we're looking at the 2nd of May. They're the 4 questions we're going to be looking at in a second. I have done a second version of them for you as well, which we can look at in a minute. But first of all, I'd like to go through the bearings question. And all I've done with this bearings question so far is set up a north line at Bath, a north line at Frome. I then connected them together and I had to extend those lines, as you'll see in a second. So let's have a look at the bearing of Frome from Bath. We're going from Bath, so we use the north line at Bath. We put the 0 line on the north line because the bearing of north is 0, 0, 0. And we go clockwise round till we take our bearing, and it's, for me, it's past 130. And when I took the reading here and I counted very carefully, I found that it was 132 degrees. Now the answers on the internet actually state 134, so I'm within 2 degrees tolerance, so I would accept that answer. And if you got 132 as well, spot on. 133 and 134. From Frome of Bath from Frome means I use the north line at Frome. So I put my protractor on at Frome. I make sure I'm on top of Frome there. I get the 0 line. It is a little fiddly, so you've got to take your time there. And you go clockwise all the way around and you go past 310. And for me, I got to 312. And again, the answers on the internet gave 314. So again, I'm within the 2 degrees tolerance. Let's now have a look at the questions, the other questions. So we had to find the median and the range. So let's do the median then first. So for the median, I need to order this data from smallest to largest. So 3 is the smallest number in the data. There is another 3. There's a 4. There's a 5. There's no 6 or 7, but there's an 8. There's another 8 and there's a 9. And now, of course, smallest and largest, smallest and largest, smallest and largest, and there's the centre. So the median is 5. And because it was an odd data set, we were always going to get an exact number. Looking at the range now, well, the range is the highest value minus the lowest value. And the highest value in this data, well, you can clearly see now because you've ordered the data, is 9, and the lowest value is 3, and that gives you a range of 6. So the range is 6 and the median is 5. Looking at Tom and Donna's heights now, and we're asked to find Donna's height in meters. So what we need to know here is that 100 centimeters is 1 meter, and the clue there is, of course, the word cent, which is referring to 100, of course. Century, 100 years. Centimetre, 100 centimetres needed for the metre. Now, we do have a really nice unit of 100 pennies being a pound as well. So if you look at 1.83 metres, you can see 183 pennies if that was pounds. So that, of course, is 183 centimetres. I can now remove 6 to get 177 centimetres, but I'm asked for Donna's height in metres. So I need to convert that to metres, which would be 1.77 metres. Thinking about pounds and pence again, which work on 100, you can see what I'm saying with the centimetres and the metres. I could, of course, used 1.83 metres and taken off 6 centimetres if I'd converted 6 centimetres into metres. Again, thinking of that 100 needed for the pound, 6 pennies would give you 0.06 pounds. So just try to think of another way of working with centimetres. You need 100 pennies for a pound. Answer, 177 centimetres. Looking at this final question here, I'm actually going to split this into a trapezium and a rectangle. You could split it into a triangle and a rectangle there, but I'm going to go for the trapezium and the rectangle. So let's look at my missing lengths then. I've got 18 here and 11 here, which means that'll be 7 and that'll be 11. I've got 14 here, which means that'll be 14 there, and I'm good to go. Let's do the trapezium first. So I've got my parallel sides there, 20 and 14. So 20 plus 14, and the perpendicular height 7. 20 plus 14 gives me 34, and a half of 34, well, a half of 30 is 15, a half of 4 is 2, which is 17, and it ends up being 17 times 7. I was just doing my half of 34 over here. So 7 times 17. With a little bit of partitioning, you can see 7 tens are 70 and 7 sevens are 49. Adding that on, you can see 30 would make the 100, so that'll give us 9. That gives us 11. 119 meters squared. And I've put that in the wrong part, of course. So now we're looking at, that was the trapezium, so now we're looking at the rectangle, and the rectangle is 11 times 14. So we're using a nice easy base times height. So base 14, height 11, again a nice little bit of partitioning now, 10 14s and 1 14, give me 154. So the area of this part of the shape is 154. So 154 plus 119, 4 and 9 gives me 13, so I have a carry, 5, 6, 7, and 1 plus 1 is 2 meters squared. If you did split it with the triangle there and the rectangle, you would have got the same answer of 273. You'd have obviously just got the area, which was 14 times 18, and then I think it's 6 times 7 then halved for the triangle. Okay, so as I said earlier, I've now got some questions for you to have a go at. They're reworked. I've not included the bearings question, obviously, but you've got your median, your range, a question about height, and a question about area. I've put 3 minutes on the clock. Remember, if you're watching this on a playback, you can pause the video if you need longer. Okay then, as I said, please pause the video if you've not had a chance to finish those questions, as I'm about to go through the answers. So the median and the range for this question here, let's do the median first. So my smallest number is 2, then there's a 3 and another 3, there's no 4, no 5, no 6, there's a 7 and an 8 and a 9. So smallest and largest, smallest and largest. The median will be between 3 and 7. And when you have to find the midpoint, of two numbers, use a very straightforward process, of adding the numbers together and dividing by 2. And on this occasion, the median is 5. So even though 5 is not represented in the data, that is the center of the data, that is the median value for that data. Range is very straightforward, our highest value minus our lowest value. Our highest value is 9, as we can see from the ordered data. 2 is our lowest, giving us a range of 7. Looking at Tom and Kira's heights, and this time I gave you meters and millimeters, and I was wanting you to convert from millimeters into centimeters first, and then centimeters into meters. So 10 millimeters in a centimeter and 100 centimeters in a meter. So let's go through them first of all. So 30 millimeters would actually be 3 centimeters, which would be 0.3 meters. So if you did it in that way, very, very well done, the conversion there. If you stayed here and converted that one to 203 centimeters and then took the 3 centimeters off, you'd have got 200 centimeters. And 200 centimeters, of course, is 2 meters. If, of course, you use these two, you'd have come to exactly the same answer, but you may have shown it as 2.00 meters. So 2 meters being the answer there, that is Kira's height. And the final question here, and again I'm going to use the trapezium method for this question. We've got some missing heights first of all, so we've got 5 meters here, which means we've got 3 meters there, and we've got 18 meters across there. So my trapezium has parallel sides of 24 and 18, so it's a half of the parallel sides multiplied by the perpendicular height. So 24 and 18, and the perpendicular is 3, the height between them is 3. 24 plus 18, well, if I add on the 10 I get 34, and then if I add on the 8 I get 42. So it's a half of 42 times 3, a half of 42 is 21, and 21 times 3 is 63 meters squared. So 3 20s and 3 1s, of course. So this section here is 63 meters squared. The rectangle at the bottom is 5 18s. Now whenever I multiply by 5 with a number like this, I don't multiply by 5, I won't lie. I multiply by 10. Because I know 10 of a number is double what 5 of a number is, because I'm effectively doubling this here. So to work it backwards, I obviously just half. And I always do that. Whenever I'm multiplying by 5, I write out what 10 of that number would be, and then I half it to get the 90. Now, of course, you could have done it other ways. You could have done 5 10s and 5 8s, whatever. Whichever way you want to do it, you'll still get to 90. Last thing then, add the 90 and the 63 together. That gives me 3, and that gives me 15 for 153 meters squared. Thanks for watching today. I am going to be doing another session next Monday as well, even though it's Easter Monday. Hopefully you'll still have some Easter eggs to eat. So every Monday I'm going to be using the Corbett maths. In fact, I've got it with me here, which I'll just show you. And that was today's. This is the Corbett maths sheet that I'll be working through next Monday. So looking at the 3rd of May Foundation 5-day Corbett maths. Please get on the website. I'll try and put the link into the video as well, and we'll be going through those questions there. So if you haven't got access to the Corbett Maths website, it's very, very good. It's there. Obviously, if you're on YouTube, you should be able to get on the internet as well. But just so you can see the questions there, I'll zoom in a little bit so you can read the questions. So there's 3 questions there we'll be looking at: product of primes, factorizing, and a ratio question. And of course I will look at those questions as well, where we're looking at side, front and plan elevations. Thanks again for watching. I hope you're enjoying the videos, and I'll see you next week. Sorry, not next week. I'll see you on Wednesday, in fact, for circumference of circles.